This is a podcast for measuring periodic motion. Most of the information from this section can be found in 12.2 of the textbook. This should prepare us going forward for doing a lab with pendulums, as well as start to give us an introduction into how we measure periodic motion, and specifically starting to talk about waves. Let me give you some guidelines for what I think will make good podcast listening. I strongly suggest listening and following along pretty carefully, so try not to be too distracted. Again, you can use your book as a resource here. Most of the stuff can be found on page 446 and 447 in the textbook. Take a second every so often to pause and see if you really understand. So just like a TV show has commercials, take a second and kind of recap what you learned every couple of minutes and see if it makes sense. And if not, go back and listen again. And then again, don't be afraid to listen to this a couple of times. It shouldn't take you too long, and the content should be valuable, especially if you get through it at least twice. By the end of the podcast, you should be able to explain why a pendulum is an appropriate model for the periodic motion of waves. So why can we use a pendulum to represent waves? They seem pretty different. And calculate and define amplitude, period, and frequency of an object in periodic motion. So those three terms, amplitude, period, and frequency, you're going to hear pretty often. So first half is pendulums and waves, and comparing the two. So lots of things travel in the form of waves, and this is sort of our introduction. We're going to talk about light and sound a lot over the course of the next few weeks and months, and mechanical energy travel in waves. And mechanical energy is what we're going to use to sort of represent that. Ocean waves are forms of mechanical energy traveling in waves. We'll also take a look at things like slinkies that can also travel in wave form. And waves are just a form of periodic motion. So periodic motion is something that moves back and forth over the same path. That's periodic motion. Periodic just means something that happens regularly, something that happens periodically. So if you think of something that has a period, it's something that repeats itself over and over again, back and forth over the same path. That's periodic motion. So back and forth motion. Take a second to think about what do you consider, or what comes to mind when you think about things that move back and forth. And here's some things that at least come to mind for me. Let's see if you thought of any of those things. Well, pendulum's a pretty obvious guess, but what about that last one's my favorite. And all those things are moving back and forth with periodic motion, or in some cases up and down. So we'll look at a couple of cases where things rise and fall. And that's actually what waves do, as opposed to sort of left to right. We'll look at up and down as well. So I'll keep that image going, moving over to the right. So kind of keep that in mind as you look at the next couple of pieces. A lot of times we think that, or at least it looks like waves are sort of moving more left to right as opposed to up and down, or front to back. So it looks like they're traveling, in this case, left to right. So it doesn't look like necessarily they're going back and forth over the same path. However, if you take a closer look, the real definition, waves don't actually move physical objects from place to place. They're only usually moving energy, and there's some slight differences, especially things on the surface of ocean waves can move a little bit. But most of the matter, most of the physical stuff that waves are made out of stays in one place. So waves are mostly only transferring energy from place to place and not the actual matter. So if you look at the coils of that spring, the individual coils stay mostly in one spot. So if you take a look over, pick a coil and it sort of just moves up and down, and the coil itself is not actually traveling to the right or left. So even though the wave is moving, the coil itself stays in one spot and it moves up and down repeated motion. So that's that periodic motion. So we're going to take a look at how do we measure periodic motion, and we're going to come back to those three terms that we looked at in the objectives. So three different measurements. See if you can remember them. These three words you're going to hear an awful lot over the course of the next couple of months. You're going to see amplitude, period, and frequency, and especially those last two, and that'll be the only calculations for this section. We're going to use these throughout the course of the next few weeks and months, and we're going to start using those to talk about a pendulum. So again, a pendulum is going to be sort of our model for all periodic motion, just because it's an easy thing for us to examine, and we can really easily see the amplitude, the period, and the frequency. So let's start with amplitude. The amplitude of an object's motion is its maximum displacement from equilibrium position. So that's a whole lot of words, but maximum displacement, you've heard those before, and equilibrium is just sort of that middle ground. So a way to translate that would be how far away from the center does the object get? And so if you take a look at that pendulum to the right, well, it moves some distance away from the middle and then comes back and moves some distance away from the middle to the other side and then also comes back. So that middle section is its equilibrium position, and then how far away from there does it get is its maximum displacement. That's the amplitude, and there's a picture of a graph of that same motion at the bottom. So if you're interested in looking at that in graphical form, it's the distance from sort of that middle point, or resting position is another good way to put that. We're going to look at amplitude measured in two ways. One is by actual distance, so if you measure the physical distance between here and here, that distance is its amplitude. So you can measure that in centimeters or meters, or how far away in distance does it get. You can also measure amplitude in terms of angle. So for something that's rotating, like this pendulum, or maybe like an oscillating fan like we saw before, something that's rotating, you can also say that the amplitude is this maximum angle displacement from this original resting position. So you can take a look at it that way as well. So two different ways to talk about amplitude there. Okay. When we're talking about period, we're talking about every time an object completes a full back and forth motion, it's completed one cycle. So when we're talking about period, we're talking about the time it takes for that one cycle to be completed. So first take a second to try and process. All right, one cycle is just a full back and forth motion. And so examples of that would be a wave going from crest to trough to crest, like you see in the graph at the bottom. Or if you think of a pendulum, starts at the left, swings all the way to the right, and then all the way back to the left. That's a full back and forth motion, so that's one complete cycle. When we're talking about a period is the amount of time it takes for that one cycle of motion. So how long does it take for that complete full cycle of motion? That is the period of time. So we're going to represent period with a capital T. And so the period is the time it takes for one complete revolution, one complete cycle. So because period is the amount of time per cycle, we're going to use units of time to measure period. So most often our period is going to be measured in seconds. That's not always the case for things that take a really long time to move back and forth. But most often we're going to talk about things that are moving for periods in seconds. So let's take a look at some examples. If a pendulum takes 4 seconds to swing back and forth once, its period is 4 seconds. So the time it takes to swing back and forth one time is its period, so it takes 4 seconds. That's a 4-second period. What if it takes 12 seconds to swing back and forth 16 times? So you're looking for the time it takes for one complete cycle. So 12 seconds for 16 cycles. Its period is going to be 0.75 seconds, or it takes 3/4 of a second for one cycle. So again, your units are going to be in units of time, And so if it takes 12 seconds for 16 times, then 12 over 16 is going to be the same as 3 over 4, or 0.75 seconds for one complete cycle. Frequency is sort of the opposite of period. So when we're talking about frequency, instead of talking about how long it takes for one cycle, we're talking about how many cycles can you complete in a certain amount of time. So when we're talking about frequency, we're talking about is the number of cycles an object can complete in one unit of time. And usually when we're talking about a unit of time, we're talking about seconds. So again, most of the time we're using seconds. Not always the case, but usually we're talking about seconds. So when we're talking about the frequency of an object, we're talking about how many cycles the object completes in 1 second. So how many back and forth motions. And so the more often you complete a cycle, the higher the frequency is. And you see a good graphical representation of that on the right side of the screen. Low frequency is a small amount of back and forths per unit time, and then medium and high frequency, you see a lot more up and down motions, or a lot more back and forths in the same amount of time. So that's high frequency. So because we're measuring how many cycles per unit time, we're really talking about per seconds as a unit, which is a little bit strange. Kind of looks like 1 over s. So frequency, we talk about cycles per second, but we leave out the cycles, so it's per seconds. How many cycles per second are we talking about? And we call that, because that sounds a little weird, we talk about that as hertz. And you've probably heard of hertz before. Hertz is just a measure of how often something happens per second. So is it 400 cycles per second? Is it 200 cycles per second? That's 400 hertz. That's 200 hertz as frequency. So let's take a look at that same pendulum. That pendulum takes 4 seconds to swing back and forth once. So what's its frequency? Well, we're looking for how many cycles does it complete in 1 second. So if it takes 4 seconds to get all the way back and forth, then in 1 second, how much of a cycle did it complete? Well, it completed a quarter of a cycle. So its frequency is 0.25 hertz, or 0.25 cycles per second. And let's take a look at that second example. Same pendulum as before. If it takes 12 seconds to swing back and forth 16 times, well, that means that it completed 16 cycles in 12 seconds. We're looking for how many does it complete per second. So 16 divided by 12, and we get about 1.3 hertz. It'd really be 1.3 repeating, or 4/3 cycles per second. So let's take a look at this relationship between period and frequency. You might have noticed that they're inverses of each other. So that first example, we had a pendulum that had a period of 4 seconds and a frequency of 1/4 hertz. That second example, we had a pendulum that had a period of 0.75 seconds, or 3/4 seconds, and its frequency was 4/3 hertz. So those two things are inverses of each other. Let's take a look at one more example. If an object takes 8 seconds to complete 20 cycles, its period is 8 cycles in 20 seconds, or 8 over 20. The time it takes for 1 cycle is 0.4 seconds. Its frequency, on the other hand, how many cycles does it get done per second, is 2.5 cycles per second, or 2.5 hertz. So it's the other way around. And again, that's something you can check with common sense. So if it completes 8 cycles it takes 8 seconds to complete 20 cycles, well, you know that it's going at least faster than 1 cycle per second. So it's got to be at least a frequency of greater than 1 hertz. And similarly, if it completes 20 cycles in 8 seconds, you know that it's got to be completing more, or it's got to take less time than 1 second to complete a cycle. So you know its period has to be less than 1 second. So that's something you can check with common sense there. Here's what that relationship looks like mathematically, and you can find that in your book on page 446 as well. So this is all that we're going to cover in this podcast. take a second to look at your objectives again and see how well you did, you should be able to do these two things. Explain why a pendulum is a good model for waves, and that's a discussion about periodic motion. And also know the terms amplitude, period, and frequency, and be able to do those little calculations that we saw there at the end. If you can't do that, take a second, stop, rewind, and come back to this. We're going to use this information Thursday afternoon in lab. See me if you have any questions.